Hey guys, in today's video I would like to share with you my completed ZVS driver and explain to you how does it work and show you some nice waveforms on my scope. As you can see, it is very simple. It only uses two MOSFETs as switches, two diodes, a resonant capacitor and a DC storage capacitor and a few resistors. This is the circuit diagram. As you can see, it is very easy, very simple. And the way it works is that there is a current flowing through here to those two resistors, to the gates of those transistors. And since no transistors and no resistors are perfect, one of those transistors will turn on sooner. So let's say this one will turn on first, which means it will make this potential positive and this one a ground, since it is connected here. The transistors is switching to the ground, and that will shunt the gate of this transistor through this diode, so this one will stay off. And what will happen is that the current flowing through here will start resonating with the MMC multi-mini capacitor bank, and it will start oscillating like this. A sine wave will be created on the primary side, and each time the voltage reaches zero, the transistors will actually switch their position. So this one will become ground and this one will become positive, and this will happen all over again. Each time the oscillation will not stop, and it will resonate on the resonant frequency of these two, this capacitor and this inductor. The resonant frequency can be calculated via Thomson's relationship, 1 over 2 pi square root of L times C. For me, this flyback driver is resonating at about approximately 40 kilohertz with this transformer. So let's show you some waveforms and some nice arcs. So the driver is powered right now. You can already hear the transformer is sizzling a bit, but I think that's not a big problem. So let's try to draw some arcs. Some of them are really scary. And as you can see, the power consumption, it is very high. It draws about 10 amps at peak. So here is the primary current waveform, the yellow sine wave. As you can see, it's pretty clear. There are some noisy spikes, but I think that's just the interference from the switching transistors. As you can see, it is resonating at about 47 kilohertz with the peak at about 370 millivolts. The ratio of the primary current transformer is about 1 to 55, and it is loaded with 1 ohm resistor, which means that the peak current on the primary is approximately 20 amps, which is pretty crazy considering the resonant voltage is about 80 volts. That's a lot of power on the primary side. It draws about 10 amps from the power supply at 30 volts, so 300 watts, which is pretty insane for this simple driver. The red waveform, which is in phase, very nicely fits in there. It's the gate voltage. As you can see, it is 5 volts per division, which means that the peak voltage is around 12 or 13 volts, which is no coincidence, since that is the clamped voltage from the Zener diodes. If we go back to the schematic, you can see there are two Zener diodes over here, and their purpose is to shunt, to clamp the voltage, not to exceed 12 volts, to protect the gates of your transistors. And there are also these two resistors, and they are there only to drain all the charges from the gates of those transistors, since when the transistors are floating, they can have an excess charge on their gates, and they can actually stay on while you shut off the voltage on the gate. So yeah, I think that's all for this video, and I hope to see you soon again. Bye.